So this part is what we did last week. Okay, actually 2 days ago. And then the last column, the 12th column, is the percentage. This is basically ratio between ratio such that denominator is total bond price and nominator is the value of particular cash flow. Of course, bond price is sum of discounted cash flow. Okay, sum of discounted cash flow, and this one is just one particular discounted cash flow. So this ratio is entire bond price and one particular discounted cash flow. Okay, and then as you know, duration, Macaulay duration is what? Macaulay duration is weighted average of time to cash flow, right? And then time to cash flow is this one. So what I can do is just I can multiply this one and this one. Then I can get a weighted average time to cash flow, right? But then the first column is actually months, and we want to express everything in terms of years, so I have to divide it by 12. So effective duration is 5.83. Something like this. But then there is one problem. Okay, there is one problem because when we say in this particular calculation of the duration, we assume that PSA, pass-through PSA doesn't change. It is constant. But if interest go down, what do you think about pass-through PSA? What do you think will happen to the prepayment? Suppose you borrowed money from bank and now you observe interest rate went down, then will you pay back money or not? Yes. Yes, if interest go down, then you are more willing to pay back your loan, right? Because actually you can get a loan from the other bank at a low rate and pay back this loan, right? Not possible. Therefore, when interest rate go down, okay, interest rate, we guess PSA will also go down, right? So let's see. Let's take into account that effect. Okay, that effect. So consider now the case in which interest rate moves from 5 to 4.5 and PSA increases to this one. So prepayment increases, so pass-through increases. Okay, so first interest went down 4.5%, and pass-through increases to 50. Okay, then value of the mortgage is this one. Let me copy and paste this one. Value only. And then now, if interest move up to 5.5, 5 to 5, the PSA decreases now 150. And then value of the mortgage is this one. Right, value of this one. So if we calculate the duration, and then duration, if we calculate duration, okay, then change of this one minus this one, and then divided by, there is 1% point change, right? We are calculating 1% because this is comparing between 4.5% and 5.5%. So it is 1 percentage point change. And then we divide this one with the current bond price, which is this one. Divided by this one. So it is about 4.4, right? So yes, it is 4.47. Let me check the answer. 4.46, so slightly different from the textbook value, but anyway, it is similar. But actually, so duration, if we don't take into account the change of PSE or change of prepayment, then duration is large, but once we take into account the change of PSA, then duration becomes lower. Actually, that's intuitive, right? That's intuitive because if we don't take into account change of the prepayment or change of the PSA, then what does it mean? We are actually overestimate. We are in some sense overestimate the change of the price, right? Because of when interest rate go down, price should go up, but price shouldn't go up that much. Okay, I cannot fully enjoy the value of decrease, the benefit of decreases interest rate because interest rate go up, bond price should go up, but then people begin to repay my debt. I don't want them to repay. Okay, I want them hold their debt, but they begin to repaying their debt, so I cannot fully enjoy the benefit of interest rate decrease. Same with the interest rate increase. So interest rate increases, the price of my mortgage securities go down. But actually it shouldn't go down that much because now people don't repay as much as before. Okay, so I can keep the, okay, what is your question?
So do we put in the contract that when the interest rate changes, the PSA changes? Because otherwise...
Okay, so I mean, it is this is the collection of all mortgage contract.
Yeah.
Like 100 or 1,000 mortgage contract. So PSA is the fraction of the prepayment rate, and for each individual contract, there is option of the prepayment.
But it's still, they have to pay different, like according to PSA. It's always how the interest rate increases.
Yeah.
So when we say that the interest rate changes, at which you can borrow money, you also have to change PSA.
Yeah.
It also affects every individual, right?
Yes, exactly. And then we don't know how much PSA changes, but I mean, we are assuming that. I mean, of course, we have to find it empirically with data, but it is certain that if interest go up, PSA prepayment should decrease, so PSA should go down. Right? That's what I'm saying. Because in each individual contract, because it's a collection of individual contracts, and in each individual contract, there is a prepayment clause. So anyway, it is effective duration. And then let's go to today's topic, another topic. Last week, Wednesday, we didn't use the Excel VBA, but using Excel, we actually saw how we can simulate derivative price where there is more than one underlying asset and the return from underlying assets are possibly correlated with each other, right? And today, why don't we make an Excel Visual Basic code for that, okay? So why don't you open your Excel file and write down Excel VBA code together? I didn't save last week's file. Actually, I should have saved it, but unfortunately, I didn't. Anyway, let's write down the code together. So again, we have to use Excel file. Let's say multiple underlying asset, and then Visual Basic. Okay, so solve what should be the name of the multi-asset, okay, whatever. I mean, name doesn't matter. So, what should be the first line? Okay, we of course need information about the risk-free rate, right? Because we have to simulate everything under, because what we have to do is this one, right? We have to calculate value of an asset at time 0, whether it is derivative or not. It is always E minus RT, and then expectation of cash flow at time Vt, right? This is our fundamental formula, but at risk neutral world, right? And then because it's a random variable. So basically, we need the risk-free rate because of this part and because of this part. Okay, so let's write down RF is 0.01, which is risk-free rate. Okay, risk-free rate, and then we need T, which is T is time to maturity. T is, let's say, 2 years. Time to maturity, so it is year, right? And then what else do we need? Okay. And then, yeah?
Stock price.
Stock price. Okay, because I mean, I want to think about everything in terms of a dollar amount invested. So we don't need the stock price right now because everything is measured in dollar. How much you invest in actually. So all we need is the, but instead of stock price, we need volatility of underlying assets. Okay, so suppose there are two assets. So V1 is the volatility of the first asset. So let's say it is 0.3. And then V2 is 0.2. And then next, there is a possibly correlation between those two, right? And the correlation is possibly right. Let's say it is 0.2. And then next, because it is a simulation, we need what? We need number of simulation. How much simulation we are gonna do? So sim number of simulation, let's say 10 times for the time being. This is number of simulation. Okay. It's okay, right? Okay, so let's write down now for loop for I equal 1 to simulation and next I. In this sense, so let's write down cells. Let's define two random variables. U1 is norms inverse land R&D, and then of course worksheet function. Okay. Yeah. So I'm generating the first random variable. First random variable from standard normal distribution. Actually, let's define this on U0. And then second random variable U1. So I generate two random variables from standard normal distribution, but they are independent of each other, right? And I want correlated random variable. And if you go back to this one, okay. This is a way to generate two random variables. Generate two sequences of uncorrelated normal distribution x1, x2. That's what we did. And define a new sequence y1, something like this. Then x1 and y1 has just like this one, right? So I'll say U2 is what? Because it's correlated row U1 plus 1 minus rho square 0.5 multiplied by U0. Now, therefore, okay, U1, U2 are correlated with rho. Okay? Right? I'm just using this formula. Right? So I generated two random variables, right? And then time t, at time t, then return 1 becomes what? Because we are holding it up to time t, so because we also have to adjust the convexity, so return 1 is basically, right, return 1 is basically RF minus, okay, V1 square divided by 2 multiplied by t. Do you remember this formula? Right. You remember this one, right? Plus V1 t 0.5 multiplied by U1. So it is holding period return, right? I'm writing down this one. In the risk neutral world, ST equal S0 E R minus 2 T plus sigma T epsilon, which is of course generated from risk neutral world. I'm just writing down this part, right? And this is called convexity adjustment. Convexity adjustment, right? No, I'm writing this part, right? And for second return is I can just U2 and 2 second return. Okay? So if we think about now gross return, if we invest $1 in first asset, okay, now let's say gross return is simply exponential of right? It is a gross return. SN1 by investing in $1, right? And then gross return 2 is right? So we just simulate on the risk neutral world. On the risk neutral world, now we simulated, okay, how much you will actually make by investing $1 in the asset A or $1 in asset 2. Right? And then next you can simply write down structure of your derivative. Right? Then what is the value of your derivative is maybe D value, okay? Derivative value, maybe your option value. Your option value is what? Now you can, it depends on, right? This is maybe max of G return 1, G return 2, and then 0.9. Then I have to define this max function. I think it will not work, right? So I have to define this max function. So let me define the function max A, B, C. So in Excel, my new function called max is if A is greater than B and if A is greater than C, then I am defining new function, okay? I am defining new function, then max equals A, right? Else if, am I right? Else if, let me check. VBA if sentence. Excel VBA if then else sentence. If, else if, else if, else. Okay. Else if A, B is greater than A and B is greater than C, then that's max equal B, right? And then else max equals C, and then end if, and end if. So I defined the max function such that it picked the largest one. So this structure of derivative is that, okay, client can invest $1 in this product, and at the end he can pick the best one out of the first asset, return from first asset, return from second asset, and then third option is you lose just 10%. So it is quite a safe asset, right? Right? Maybe both of them are fantastic asset, and then you client pick the best one, and then even client downside loss is actually limited. If client is very unlucky, he loses just 10% because he invests $1, and anyway, at the end, he can get 0.9 back. Okay, so it is a great possibly investment opportunity, but because it is a great investment opportunity, there should be price of doing this, right? So then your question, how much you have to sell this one, okay? Yes, of course we have to do it, but anyway, let's simulate it and whether it works. And then sell I1 option B. Okay, so let's run the program. Okay, something like this. Okay, then of course next we have to get the average of this and discount it back, right? And then how can we get the average of this? Then sum, we have to define something like sum, value sum, which starts from 0. And then sum v equals sum v plus option value. Then in this sum v thing, it keep adding option value, right? Because its initial value is 0. In one routine, it adds option 1. And then it becomes, first sum v becomes option v. And in the second round, it becomes sum of these two things. And third round, sum of these three things, blah, 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 right? And then, so at the end, right? So option value, final option value is what? We have the sum v divided by sim n. So this is the average. And then of course we have to discount it back. And then we are done. Right? We are done, and let's check. And then if we run this one, this is my option value. Right? But then, I mean, it is the two. So cells less than 1, 1. Option value. So if I run, this is option value. But then it is just 10, so I can do the this 100,000 times. And it will take time, but then I have a much more accurate value. Let me do it again. So it doesn't change much, right? Because I do 100,000 times, right? So for client, in order to invest in this product, they have to pay like 20% of the premium. Actually, there is this kind of product in the market already. That's simple. Now you can design any financial product. And then again, the question is now, what if we have more than 2 assets? We have only 2 assets. Then you can impose this correlation like this. Okay? We can develop correlation like this. Oh, by the way, I will ask a question. Correlation is now 0.2. How can I make it if I make minus 0.2? So now assets are negatively correlated with each other. And do you think the value of this derivative will go up or go down? When it is positive correlation, they move together. But when it is negative correlation, when one go up, when go down, when one move up, when go down. Do you think the value of this derivative go up or down? Go down? Why? No, volatility doesn't change. Volatility is 30% and then 20%. Same, only correlation between 2 assets. So in the previous case, it is like option written on Facebook and Twitter, because they tend to move together. In this case, option is like Facebook and then Shell, something like that. Facebook and Walt Disney. So which one should be more valuable? Facebook, Google, or Facebook, Walt Disney? I normalize stock price because I think everything in terms of investing $1. Let me check it. If it is negative correlation, it goes up, right? It goes up, right? And then if I make it very high, and it should go down a lot, right? It goes down a lot, right? thing is that, I mean, this is natural. It is in some sense natural because, I mean, I can pick only the best one. I can pick only best one. So I'll be happier if the value of asset move in the different way. If they move different way, then when goes up, I don't care. I don't care bad performing asset. I can simply pick the best one, and then the best one will be better if underlying asset, performance of underlying asset diverge, right? So negative correlation is better in this case. Oh, by the way, do you know, I didn't explain how to write down new function with Excel VBA, but it looks straightforward, right? Previously, I wrote down just the subroutine, but this is developing new function. In new function, so since you develop new function, like even in Excel sheet, this one, max 1, 2, 3. You can use it in your spreadsheet as well because you develop new function here. So you can use this one here. Okay. So this is also, this function part is also very useful technique. When you work on Excel in your job, sometimes you have to use very different, very complicated function, something like that. But whenever you write down complicated function, then if you define it in Excel VBA, you can simply call your function. So it is very, very convenient. And then if we have more than two assets, then we have to use a Cholesky decomposition. And then Cholesky, there is a VBA code for calculating Cholesky decomposition. And then this is not that difficult, right? Function Cholesky. So it is function Cholesky matrix as a range. So for given matrix, we can calculate Cholesky decomposition. Interesting. 예. 아니 그게 아니라 이제 조현정 학생이 예를 들어서 골드만삭스에 있는 어떤 잘생긴 사람이 조현정 학생한테 와서 새로운 상품이 나왔다. 새로운 상품이 나왔는데 지금 100만 원을 투자하면 100만 원을 구글에도 투자해 줄 수 있고 페이스북에도 투자하고 있다. 그리고 2년 후에 근데 구글에 투자하면 구글이 잘 될지 페이스북이 잘 될지 모르잖아. 100만 원을 투자해서 구글이든 페이스북이든 잘 된 데 투자한 거에 돈을 주겠다. 예. 그러면 이제 또 걱정이 뭐냐면 근데 돈을 잃으면 어떡해요? 그러면 최소한 90만 원은 돌려주겠다. 그런 거지. 100만 원이니까 여기 이제 100만 원만 그러면 얼마를 투자해야 되면 이제 조현정 학생은 코릴레이션에서 한 120만 원 정도. 그렇죠? 아, 그럼 그 상품에 내가 120만 원 정도 투자하면 되겠구나. 120만 원 주면 거기서 20만 원 떼고 100만 원을 이 상품에 투자하면 2년 후에 페이스북과 구글 중에 잘 된 데다 돈을 주는 거지. 둘 다 주가가 많이 떨어지면 최소한 90만 원 돌려주고. 이런 상품이에요. 그렇죠? 이런 상품은 어떻게 계산할 것인가? Anyway, so we have Cholesky decomposition, and then let's try Cholesky decomposition. Okay, Cholesky. Okay. So let's do the matrix 1, 1, 1, 0.1, 0.2. No. I want to try Cholesky decomposition. And then Well, this looks right, but when then why it doesn't give me the answer? Interesting. Cholesky decomposition. Okay. Cholesky matrix range and Cholesky new L lower. Range dimension 1 to n, 1 to n. A if we put A. I don't know. Somehow it doesn't work. Cholesky. Strange. I don't know. I don't know how to use this one, but how to code a column decomposition SLVBA. I don't know. This is maybe not the best VBA code. So I may delete this one. Anyway, we just calculated the derivative price of the case in which there is only 2 underlying assets. But the question is, what if more than 2 underlying assets? Then we have to use Cholesky decomposition. Cholesky decomposition such that if there is more than 2 assets, in this case there are 3 assets, right? 3 assets, so then suppose we have asset, there are multiple assets, and it is distributed with mu, and then this one. This is a multivariate normal distribution, right? So it is a factor, they are all vector. But in the risk neutral world, we know expected return should be all same as risk-free rate, but variance covariance matrix doesn't change, right? Again, this is all factor, and this is a n by n vector. So it is a n by 1 vector, and it is n by n vector. Then the question is how we can simulate this one. This is something, in order to simulate this one, we can simulate R plus what we can do is C multiplied by Z epsilon. Okay, here, so in order to simulate new R, what we can do is use this one. Here, of course, R is the same, n by 1. And C matrix is n by n matrix. And epsilon is n by 1 matrix. And epsilon is distributed with standard normal distribution. So the mean 0 and variance covariance matrix is just identity matrix. And here, the important part is C matrix. C matrix is basically Cholesky decomposition of this one. So in this case, this one. Cholesky decomposition. BBC. The notation is different, but anyway, C. So here C is the important part. C is C prime is this one. So basically, we have to find the C matrix such that C multiplied by transpose of the C becomes variance covariance matrix. And then this C matrix is there are